You got to correct the 6. It's either going to go to 5.5 or 6.5. You got to make the right call here. Here's my 6. Let me put the bar around the 6. I got 5.5 to 6.5. Yeah, because I don't even know what the situation is. Okay? So I've got everything that rounds to 6 here. I got the 5.5 and the 6.5. Is the 6 included? Do I want everything that rounds to 6 included? No. So what are we going to correct the 6 to? 6.5. The shaded is going to start here at 6.5 and go up. So the 6 will get corrected to 6.5.
Why would it be like 6.1? Yeah.
Because that would include 6 then. I want all successes greater than, so what numbers are greater than 6? Yeah, 6.1 would round to 6. See, I don't want to include anything that's 6 because I want to be over 6. So I'm really talking about the numbers 7, 8, 9, and up. It all depends on what's in here, the greater than or less than or equal to. Whether the number is included or not. Nope. Well, as long as the symbol flips with it. Okay, like I said, we're going to do a lot of these so you get comfortable with it. Got a couple more. And you're comfortable with it. Less than 8 successes. Less than 8 successes. Less than 8. I think it might be helpful to put the bar in for the 8. I don't care where you put it. Then put in each edge, the 7.5 and the 8.5. There's the 7.5. Here's the 8.5. And then it's just a matter of, do I include the 8 or not include the 8? I don't include the 8, and then which way am I shading for less than? So it's less than, so I want this side shaded, but I don't want to include anything that equals an 8. So what am I correcting the 8 to? To 7.5. Are we slowly getting it?
Yes.
Josie said yes. One more or two more? We'll see what we need here. Let's see, at most, we'll do 2 more. I want to do 1 more of these. No more than 4. No more than 4 successes. So what does that mean as an inequality? No more than 4. Less than or equal to. So here's my 4. Here's my 3.5. Here's my 4.5. Do I shade the bar in? Do I want to include the 4s? Yes, because equal to 4. So everything in between 3.5 and 4.5 equals 4. And then what else do I want to include? Less than, so it's going to blow by that. So what does my 4 need to get corrected to? 4.5 is my edge of my shaded region. And technically just a less than 4.5. Ashley, you're holding your head like you got a headache. Okay. All right, last one. Probability of exactly 5 successes. No more, no less. What do you think? What'd you say?
Yeah.
4.5, and what'd you say, both of them?
Yeah.
You are correct. So we are going to use both edges, because all I want is just the numbers that round to 5 only, and that gives me this region. So 4.5 less than or equal to x less than 5.5.
Less than 5.5
Oh, well, it could probably be a dotted line here, you know, instead of a solid, something like that. But when we use the NCDF, it's not going to matter, because you're going to take that 5.5 and turn it into a z-score. Okay, now that you've got that under control, we're going to try this. Actually throw in some probability. Okay, so let's see, how many steps are there? 4 steps, basically. So if the directions say, if possible, use the normal to approximate the binomial. So the steps for using normal to approximate binomial. The first thing you have to do is that check to make sure the sample size is big enough. That n times p and n times q both have to be greater than or equal to 5. First, check to see if sample size is big enough. That's your n times p has to be greater than or equal to 5, and the n times q. If either one of those is not bigger than 5, you cannot move on. You have to go back and use your binomial PDF or CDF. And we'll do that tomorrow. I'll make sure everything today can be done with normal. Okay? Then you've got to make the correction for continuity. So rewrite the probability with the correction for continuity. Then you're right back to where we've been. You're going to take this corrected number, turn it into a z-score, and use your NCDF. Turn your corrected x value into a z-score by using that mean and standard deviation formula that I gave you earlier. The mean is n times p, standard deviation, square root of npq. Okay, so we'll do one of these, and I think that's plenty. Good?
No.
Nope. Good back there yet? What'd you do? Take some time out to text?
Yeah, it's good.
Text a novel or what?
No, somebody showed me a document.
Okay. Oh, 2. Thank you.
Oh, no, I was looking at myself.
Are we on example 2? I know we had a 1.
Yeah, we are.
Okay. All right.
I wouldn't have been, okay, sorry. I was
29% of Americans feel that they'll see people be able to take trips to the moon. So 29% believe they'll be able to take trips to the moon. You are randomly going to select 200 people, it's a lot, it's a big survey, and ask them, do you think you're going to be able to see people take trips to the moon? I want you to find the probability that at most 65 people say yes. And we're going to use the normal. This is how you're going to tell on the test. It'll say, use the normal to approximate the binomial if possible. That little phrase there is what's going to tell you to follow those 3 steps. If you don't see that in the problem anywhere, don't worry about this section. So on a test, I want to see the 3 steps. I want to see that you knew to check to make sure that it was normal, the sample size was big enough. Not the magic number 30, it's those 2 products. So, let's go with our first step. Check for normal. What is my n in this problem? It is. N is the number of trials. I'm talking to 200 people, so it's 200. And the p-value, what's the probability of success? 0.29. That equals 58. Is that big enough then? That's okay. We want it to be greater than or equal to 5. The other part of the check, and do we really need to do this part of it? Well, to do the n times q. What's q going to be in this problem? The rest. What's off of 29? That'd be 71. I think this is even going to come out bigger because 71% is bigger. The rest of the people, what is it? 142. It's the rest of my 200 people. So we're good to go. We can use the normal to approximate the binomial. Our second step is to make the correction for continuity. That's doing that 1/2 business. You got to change your number. Oh, not yet. That was just a check. We're going to do it in the third step. Okay, I first have to rewrite my probability question. What is it asking me for? How many successes? X is, if it's at most 65. How would you rewrite that? Less than or equal to 65. Now the 65 has to get corrected. If you want to make the graph, you can. Here's my 65. Here's my 64.5. Here's my 65.5. Okay, am I shading the bar in? All of the bar is going to get shaded in because it's equal to 65. So all of these numbers equal 65. And then I want less than. So my correction would be that X is less than 65.5. There's my correction for continuity. And I see my shaded region that I want to find. I know my left z-score is going to be negative 10 to the 10th. I just need to turn 65.5 into a z-score in my third step. See how this stuff is all kind of the same? So this is it, yep. So we got to turn 65.5 into a